your presentation view, so please, screen is yours.
Okay, perfect. Thank you. So, my today's presentation is about detecting fair play violations in chess using neural networks. I'd like to preface this by giving a short backstory about a very recent, or well, not as much recent scandal, but a very relevant one that brought attention to detecting cheating in chess. It was a match between the previous world chess champion, Magnus Carlsen, arguably the strongest chess player in human history, and a very young player, Hans Niemann. And during their match, Hans Niemann was able to easily defeat Magnus Carlsen with the black pieces, which obviously was an impossible thing to do. And what happened after the match was that the world champion accused Niemann in receiving assistance from computers. And this entire drama then evolved into a lawsuit, and this brought international attention from all spheres of science, including psychology, body language, data analysis, and obviously cybersecurity. So I decided to also tackle this problem, and I wanted to use neural networks to create a chess cheater detecting algorithm, a neural network that will be able to take relevant parameters extracted from a chess game and then analyze it and give a verdict of whether or not this game was authentically played by humans. And I think it is very relevant because not only in over-the-board chess, but especially in online chess games, it is very easy to just open a different window and receive assistance from ultra powerful computers, the capacity of which exceed any human capabilities. And with this will have a huge impact because decreasing such unfairness will, I guess, restore balance in sense and give more credibility to playing games online as well. So I would like to begin this with a very recent study about this Hans Niemann case. It was an online article published which discusses the relevance of centipon loss and how Hans Niemann's average centipon loss does not correlate with his player rating. I will explain what this is in a minute. And I decided to actually use this as a basis for my neural network. So centipon loss is, in mathematical terms, a hundredth of a pawn lost by a human. It measures human error because no human is physically capable of playing as well as a chess engine, all of human choices are more or less suboptimal from what the engine wants the human to play. And this results in minor inaccuracies, and then these inaccuracies, these deviations from the engine preferences is then recorded as a centipon loss. And the study focus centrally on centipon loss and its mathematical derivatives like standard deviation and average and etc. to make some very interesting observations. And most relevant and almost all relevant current anti-cheating systems also heavily rely on it. However, these systems have one big problem in the sense that it has a tendency to give false positives, and it is hard to distinguish strong players from players that use computer assistance. It kind of flags them both. And this gives many false positives because it only measures the accuracy, and therefore high rated players will have low centipon loss, just like an engine would. However, this is where I want to introduce another artificial intelligence called Maya Chess. It is an chess AI that is not focused on making the best and most accurate moves, but rather making the most human-like moves. And this can be used to measure the human factor. So this will basically solve the previous issue of strong players being undistinguishable from the engines, because we can split, I guess, the correlation into two-dimensional space where we will have correlation with Maya and correlation with conventional chess engines. And this will then isolate the games where we have low correlation with human style and high correlation with engine styles as authentic or inauthentic games where one player used some sort of artificial assistance. So to begin, I obtained data, a lot of raw chess data, thousands of chess games from open source platforms. I used fixedchess, lichess.org, and chess.com. I contributed a lot of my own games as well, as I have over 10,000 games on lichess, and I used them in the training data. I used the scripts that was provided by the online article to extract and analyze this data using different engines. Data will then be later used to train the neural network. And I downloaded the Maya. Maya was actually a very old project, and lots of libraries were outdated, and it took a lot of time to set it up and get it working again. However, after a very long series of trial and error, we were able to achieve its final configuration. And we also ran this Maya artificial intelligence in the scripts from the article. So finally, after obtaining all the data from both conventional chess engine, the centipond metrics, and from Maya, it underwent the standard process of data normalization. And then I initiated my own neural network. I decided to go with a sequential model. And after I guess a couple of epochs, we were able to obtain two results. I tested it two times. I tested it once without the Maya factor, where we achieved roughly 80% accuracy at identifying cheaters, and with the Maya parameters, this accuracy was increased to 98%. Obviously this is not the end, as I plan on improving on this project very significantly. One of the more relevant, one of the more relevant things I plan on adding is using another model of Maya Individual, which measures individual style. This will be very helpful in investigating specific individuals' careers, and this allows us to create sort of a three-dimensional plane, which will make isolating cheating cases much more easier and obvious. And also, since my sequential model is not very optimal, I also plan on integrating these parameters into actual cheating systems, such as the open source AI system called Irwin, and see if they increase its performance as well. So with this, this is it. Thank you for your attention.
Okay, thank you very